Hello, and welcome back to Political Science 4781, Techniques of Political Analysis. In this series of videos, we're talking about space, in particular how to plot things that have some spatial relationship to one another. In the previous video, we showed how to plot recent earthquakes on a world map, and in this video and the next, we're going to talk about choropleth maps, that is, maps in which colors or states or counties are colored in different colors based on the value of some variable. And the variables we'll be looking at are GDP in this video and election returns in the next. So, how do we make a choropleth map of the world? Well, there are a couple different ways to do it. We're going to use our world maps package, and when you're doing this, the reason to do it is more straightforward that way than it is with the maps package. Here's the procedure. You download the GDP data, which we'll get from the United Nations. Actually, I've already gotten it sort of pre-processed. We don't need to worry about obtaining the data for this demonstration. We're going to add ISO country labels, which are three-letter codes that uniquely identify countries so that the values of the variable that you're interested in can be tied to coordinates on the map. Now, in doing that, we're going to use the R library called country code, which is a wonderful thing because it saves you the trouble of looking up all the country codes and entering them by hand. After that, we're going to take a look and see whether GDP conforms well to a linear scale, and this matters when you're choosing your colors, because you need to figure out where the cutoffs are in your colors, and if you choose a linear scale, but your data don't really look, sort of when you line them up from the highest value to the lowest value, if they don't look linear, then the mapping isn't going to work very well. There won't be very many colors on the map, and it won't be very informative. Once we've done that, we're going to connect the country data to the polygons that make up the map, and then we'll create our map. Okay? So the first step in doing this is to read in the GDP data, which I've put on the web as a CSV file. And when you summarize it, you'll see it has only three things: the rank of the state, the name of the state, and its GDP in 2010. This is in millions of US dollars. So the lowest value for a GDP out of all of the states listed is $31 million. The highest is $14.4 trillion. Okay, now we use the country code library, and this is kind of fun in that I don't know, it's kind of fun for me because it saves us a lot of work. We're going to load in the country code library. We're going to create. Now, you remember when we read in the data, we read it into an object in memory called GDP. Right? We created a new object called GDP, and we read the data into it. So we're going to create a new column in our GDP data frame, and we're going to call it ISO 3C. Now, we're going to fill it with values from the country code library, or from the country code command. Now, all we need to do is give country code three things. The first thing that we give it is the name of the country. The second thing is the string country.name, which says, I just gave you the name of a country. And the third thing we give it is ISO 3C, in quotes, which says, I want you to translate what I just gave you into ISO 3C. So the first thing is the variable name. The second is what kind of thing is it? Like, what am I translating from? And the third thing is, what am I translating to? And when you do that, and you summarize the data, you see, we created a new variable. It's 210 observations long. It's characters, and we might want to take a closer look at it just to make sure that everything went right. Well, when we type in GDP $ISO 3C to take a look at the variable, we see most of the country names got translated into ISO 3C code. These are what ISO 3C codes look like: CHN for China, JPN for Japan, so on and so forth, right? But it missed a handful, probably because the way the name was stored in the original data set wasn't quite something the country code expected. Now, the most straightforward way to fix this is just to do it by hand. We're only looking at a handful of values. So I'm going to use a a concise little command up at the top. We're going to look at the GDP rank of every country for which GDP ISO 3C is equal to NA. Okay? And the way that we know that inside the square brackets is we use the command is.na GDP $ISO 3C. That returns true if ISO 3C takes on a value of NA and false otherwise. So what this command does is it says give me the rank for every country for which ISO 3C is missing. So it tells you country number 1, country number 21, country number 61, so on and so forth. So all I do then is just look at the data, list out the rank and the country name, and then go online to unc.edu/rollet/unit/code/country.htm, which is a list of ISO 3C country codes. And then I convert the ISO 3C code of the first country to USA, the code of the 21st country to BEL, and so on and so forth down the list. There are a couple that are missing because they should be missing, and we'll leave those missing. But this is a fairly straightforward way, not too time consuming, to fill in the remaining 7 or 8, 5, 6, 7 ISO 3C code. So now you have an ISO 3C code for every country in the data set. Now we're going to plot the distribution of GDP. And if you'll note in the plot command, we're only giving it one variable to plot, right? It's just going to plot GDP on the x-axis. And if you take a look at the distribution of GDP, you see that it's highly nonlinear. That is, the country with the highest ranked country in terms of GDP has a GDP that's much, much larger than the second ranked. And the second and third have a GDP that's much larger than the fourth ranked, and so on and so forth, right? Now, just about everything in this plot command should be familiar to you. CEX equals 0.75 just shrinks the points a little bit. Normal value is 1. PCH equals 19. That changes it from a circle to a filled-in dot. Color equals red makes the color red, and then you have the X labels and the Y labels, right? Now, by comparison, if we take a look at the log of GDP, and here all the rest of the command is the same except I've changed the color of it from red to blue, but we're plotting, if you look in the plot command, we're plotting log of GDP rather than GDP. And we see is that actually looks a lot more like a straight line, okay? So when we're choosing colors, it's difficult to put it, but it makes a lot of sense to choose colors that are going to space themselves out equally along this line rather than along the previous value of the y-axis, right? Because if you imagine picking 8 equal intervals along the y-axis here, well, a lot of them would be empty, and the vast majority of the countries would be in the lowest category. Now imagine picking 8 intervals along the y-axis, and you can see they're much more evenly distributed. You've got more countries in each category, or a more even number of countries across categories, right? So that's the intuition behind how it is that we're going to choose our colors. Now we're going to start by loading in our color brewer, and we're going to create a palette of colors. We'll choose 8 colors, and we'll call the object that we put them into my.colors, and we'll have them be on the spectrum from yellow to orange to brown. Okay, this should be fairly straightforward at this point. If it's not, load in the R Color Brewer library and type !brewer.pal. It has a lot of examples and a lot of information about the different kinds of color palettes you can read in. Now, we're going to call up the R World Map library. The downside to R World Map is it doesn't produce the most gorgeous sort of high-resolution maps. The Maps package actually does a better job of that. The upside to R World Map is it's got a couple of commands that make it really very easy to use. One of those commands is join country data to map. So we're going to create a new object called My World Map that joins GDP to all of the countries of the world. We're going to tell it that the join code is ISO 3C, that is or ISO 3. That is the way that we're going to be connecting GDP to countries in the map is by their ISO 3 codes. The next subcommand, name join column, tells us you can find the ISO 3 codes in a column called ISO 3C in this data set. And then finally, name country column equals name just tells it you can find the name of this country in the column called name. So when we create this, it's sort of an interesting object because it has, you can't really see it here, but when you summarize it, it does have GDP in it. But it's also got all sorts of data for the country polygons that we're about to draw, including things like their area. Okay. So once we've done this, and remember that's one command to connect the data to the map. Then we have one more command to create the map. It's called map country data. And you just give it the My World Map object that you've just created. You tell it the name of the variable that I want you to plot, name column to plot, is UN 2010 GDP. Cat method I'll get back to in a second. Hold that thought. Color palette is going to be my colors. That is the eight color scheme that we came up with. Add legend is true. We want it to have a legend. Border color is white. Those are going to be the borders between the countries. Missing country color is gray, so if we have any missing values, they'll fill it in with gray. Map region is world. We're going to plot the entire world, and we'll give it a map title, World GDP 2010. Now, cat method is the only thing that's a little bit tricky here. And if you look under the help file for map country data, you'll see there are a bunch of different options for how it is that you want to break the colors up across countries. So what we're telling it here is I want fixed widths. That is, I want 8 equal-sized chunks, but I want you to use the log of the dependent variable, right? So essentially what this is doing is it's saying, all right, take this distribution here, and along the y-axis you see values ranging from around 3 to just over 16. And I want you to break that range up into 8 separate chunks, or 8 equal-sized chunks. And those are going to be the bins that we use for our colors. Okay? So that is probably the trickiest part of the map country data command. And it's not that tricky once you get a sense for what it does. In particular, you don't have to manually map your colors onto individual countries. As long as you specify cat method, it does that for you. And what you get is a map that looks like this, right? You've got the countries with the biggest GDPs colored in sort of darkish, like a dark red, sort of a rust color, all the way down to the countries with the smallest GDPs colored in a very pale yellow. Now, there's one odd sort of thing about this, and that is that the legend, and there's one frustrating thing about the our world maps package, is the legend isn't really very customizable. I would, why is it that we have it going from 31 to 14.4 trillion? It'd be nicer to have just sort of round numbers and show where the intervals are, but it doesn't really give the option to do that. So one thing you can do is exactly the same command, except change add legend from true to add legend equals false, right? So we just get rid of the legend. But now, even though you might be able to figure out darker is bigger and lighter is smaller, it'd be nice to have a legend that has some sort of information in it. So let's go back to that the original plot of GDP, and let's create 8 categories using the cut command. And we're going to use the same 8 categories from the logged version of GDP. So what we're going to do is apply the 8 categories that are evenly spaced when GDP is logged to GDP when it's not logged. Okay, and we're going to do that with the category. We're going to put that into the category object. So if you look on the plot, what you see is the first 4 countries fall into the top category, and then there are a bunch of countries that fall into the second category, and then even more fall into the third category, and so on and so forth. Right. So when we do this, again, it isn't. There's not much different from the first plot that we made. There's only one variable listed. The main difference is that we're going to tell it to use the colors from our color palette, and we're going to tell it which color to use based on which category the country is in. Okay, so if the country is in the category number 8, the highest category in terms of GDP, we're going to use color number 8 in our color vector. And then we leave the X and Y labels blank. I actually just sort of using a Photoshop, I think, just added the text on the Y-axis and made it horizontal rather than vertical. So this serves as a handy legend that you can put in at the bottom, because it does a couple of things. First of all, it tells you that the countries with the highest GDPs are the ones that are darker colored, but it also tells you that it gives you a snapshot of the distribution of GDP around the world. So this is another example of having one element in a graph do as much for you as it possibly can. And in this case, the legend is doing a couple things. It's showing us what the color coding means, but it's also giving us a look at the distribution of GDP around the world. And that, in a nutshell, is how to make a map of world GDP.